quickly talk about obtainable quantities in electric circuit rather. What you can obtain from electric circuits. Last class before practical, where I give you some hints about electricity, and we move as far as discussing what the electric circle is. And it's simply defined as the path taken by electric current from the source through at least one component and back to the source. That's the simplest definition I can give to that circuit. It's a path taken by electric current. Then, what can we obtain from the path we talk about? We want to look at some of the quantity we can obtain from that electric circuit today. And let me also inform you that when you want to determine anything from electric circuit, the circuits need to be broken down into segments. What do I mean by segment? The sources of the electric current in the circuit is a segment. The external resistors in the circuit is another segment. We want to engage the formula for combining two or more components. Now today, we want to look at quantity obtainable from the electric circuit. The following quantities are obtainable. The following quantities are obtainable from electric circuits. 1. Electromotive force. Usually represented by E. Electromotive force, usually represented by E. We defined electromotive force last class. Can somebody remind us what electromotive force of a cell is? What is electromotive force? Electromotive force. Anybody in the class? What is electromotive force? Right? Because of time, that shows how well you are preparing for the class. There are two definitions I gave last week. One, we said electromotive force can be defined as what? Work done in bringing a unit positive charge from one point to another in an open circuit. Or we can define it as potential difference across the terminals of a cell when the cell is not delivering current to the circuit. Potential difference across the cell, two terminals of the cell when it is not delivering current to the circuit. Some of you are still bending heads down as if you are writing definition. So you did last Wednesday when we are discussing it. What is the result today? You can remind what you have jotted down in the class last Wednesday. That is too bad. So electromotive force is work done in bringing the unit positive charge from one point to another in an open circuit. Every cell has electromotive force. So I will represent it by E. So we can obtain this. This can be obtained by using E equals I into R plus. That is an expression you can use to determine the electromotive force of a cell. So we have where, of course, E stands for electromotive force. Electromotive force, E. I stands for electric current. Electric current, which is measured in ampere. R stands for external resistance. We use that as external resistance, and small letter r, it stands for internal resistance. If you have more than one cell, in a circuit, then we can combine them. If you have, this is when you have a cell in the circuit, but if there are two or more cells in the circuit, if you have two or more cells in the circuit, then we have E total. E total will become I into R plus small letter R total. That's one. For two or more cells in the circuit, we can find this. E total means equivalent or total EMF. So we get EMF like this. We can also express it depending on the arrangement the cell has in the circuit. So it can also be obtained by using E total equals E1 plus E2 plus E3 plus to En. If the cells are in series, if you arrange the cell in series, then we add up electromotive force of each of the cells. When they are in series, we add up electromotive force of each of the cells to obtain the total electromotive force in the circuit. So it depends on the arrangement of the cell that will determine how you are going to combine the electromotive force of all the cells. But for sure, if you arrange them in series, you are going to add them together. The EMF of one cell will be added to the EMF of the other cell. But let me say, if the arrangement in series is in opposite, what do I mean by opposite? Let's quickly look at it. If I have a cell like this is 3 cells. Look at this arrangement. This is E1, this is E2, and this is E3. 3 cells arranged in series. E total in this case, E total will become E1 plus E2 plus E3. That's what you are going to have. But if you have it this way, the gap student take notes. You have this arrangement. Do you know that this arrangement is also series? If you observe very well, This arrangement is different from that, but they are both in series. What's the difference between them? What's the difference between them? I don't know what is the problem. Does it mean that you know this, you don't want to respond, or you don't know? The class is too cold. Yes? What's the difference?
Negative charge. You decided to show that this the second one, and this one there's positive charge in the second one.
Here, the connection you have here is, this is positive, negative, positive, negative, positive, negative. But in this case, you have positive, negative. The next one, negative, positive, negative, positive. Very simple. That means it is opposite direction to each other. So if you take the first one as E, you take the first one as E1, your E2 will be negative. Your E3 will be negative. So it means plus E1 minus E2 minus E3. That is what the total EMF you will have here. But for your YX, you will always be given this type of series. But JAM can give the arrangement this way. Instead of adding them together, if only one is reversed, that will carry negative, others will be positive. So if there are two, that means you are going to have 2 plus 2 plus 2. That is 6. But in this case, you are having 2 minus 2 minus 2. That's how you are going to have it. What will be the total? Minus 2 volts. Is that clear?
Yes, sir.
So where you need 6 volts and you have minus 6 volts, such instrument will not work. And that is the reason why when you arrange your cell in transistor radio and the polarity is not well placed, the radio will not be on when you twin it. Is that clear? Not only radio, even any other instrument you are using that requires using of the battery, you have to arrange the battery in such a way that you have it. Now, this is what we call series arrangement. There's another possible arrangement you can have in cell, and that is parallel arrangement. For parallel arrangement, you can also determine or obtain the total electromotive force. If the two cells are arranged in parallel, if they are arranged in parallel, then you use E total equals E1 equals E2 equals E3 equals En. So if the cells are arranged in parallel, E total will be equals to electromotive force across one of them. Even if you have millions of them arranged in parallel, parallel arrangement of cell is this. You have a cell here, you have cell here, you have cell here. So you have this, and this, and this. Connect like this. This is positive, 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 negative, negative, negative. The three of them, this is E1, E2, and E3. This is parallel arrangement of the cell. So if this one is 2 volts, this is 2 volts, and this is 2 volts, then E total, all you need to do is to say E total equals E1 equals E2 equals E3 equals 2 volts. Therefore, E total will become 2 volts. That's what you are going to have as your answer. If you have 10 of them in parallel, E total will be electromotive force across 1. So from electric circuit, you can find electromotive force. We can find the total. The name you give to E total can be, you can refer to E total as equivalent or effective. You can say where E total is called effective electromotive force, or we call it equivalent electromotive force, or you call it total electromotive force. So these are names you can give. If the examiner say calculate the effective electromotive force, or effective or equivalent or total, they may not say electromotive force fully, they will just say EMF. Yes?
So what if the E1 is 5 volts and the E2 is 2 volts and the E3 is 3 volts?
Yes, the question is what if the electromotive force across each of the cells arranged in parallel are not the same? What will happen? Who wants to answer that? Yes. We pick the highest vote. Why? Why do you think we pick the highest? Yes? You think so? Or you read it somewhere? Huh? Somewhere. Where in your floor, Abi? Yeah. Now, let me answer that. If I may ask, have you seen any electrical gadget, be it radio, calculator, computer, whatever, that they use different size of battery to operate? Have you seen that they use different value of battery to operate? Torchlight you are using, can they use big and small battery to operate it? Your what? It's not done. And let me also pass this information. Component in parallel will have the same potential difference across them. Component in parallel will have the same potential difference across them. Don't let it slip away from you. In electricity, once you are told that two components are in parallel, potential difference across them are the same. Resistor in parallel, potential across them are the same. Galvanometer in parallel, the potential difference across them are the same. And potential difference is what we refer to as, we get to that one, it's another obtainable quantity. So, you can hardly see in practice where we use cells of different values arranging. Even you cannot arrange them in series. You arrange cells of equal values, although their polarity may be changed, but you cannot take 2 volts and 1.5 volts, arrange them together. Is that taken?
Yes, sir.
So, the fact that you say they are in parallel, the potential difference across this must be equal to potential difference across this, must be equal to potential difference across this. And so, the total potential difference across all the three will be the same. So, it isn't that we pick the one with the highest value. No. There is no theory, there is no physics, something. Even Kirchhoff's law did not say that when they are parallel, if one is bigger, we take the bigger value. No. We take the ones across it. Now, that's the first obtainable quantity, electromotive force. And we define it as the work done in bringing a unit positive charge from one point to another in an open circuit. It is possible to have a cell in the circuit, and it's possible to have 2 or more cells in the circuit. Whichever one you have, we have taken care of that. Number of cells determines how you are going to combine them together, and the type of arrangement you have determine which formula you are going to use. Is that clear to everybody? Yes, sir. Wednesday now we ask you, you'll be looking like this. God bless you. Now, the second Obtainable quantity is external potential difference. External potential difference can be determined, can be obtained from electric circuit. External potential difference. That's number 2. External potential difference. External potential difference. External potential difference. That's number 2. Usually represented by capital letter V. Usually represented by capital letter V. Can somebody remind us the definition of potential difference, external potential difference? Anybody? External potential difference. No idea? Nobody can define that for us, or you have not been taught that. What is external potential difference? Clap for him, although it's not correct. That is even able to say something is commendable. Yes. I think that should have reminded you. Yes, David.
Is the potential difference internal to the cell when it's giving side according to the external side?
Well, I will take that, but why I will not take that is because I told you at the beginning, when you are calm, that we don't use a word to define the word. Yes, and the voting for I said potential difference across the cell when it is not delivering current. Now, external potential difference, you are saying the potential difference across the cell when it is delivering current. It is right, that is physics, but you cannot define that way. For calculation's sake, you should know that. But you are still using potential to explain potential, whereas you have other way of explaining it. I said do not use a word to explain a word. Potential difference. You said there's a potential difference across the cell when it is delivering current to the circuit. Somebody may not pick it up like that, but it's very right for calculation's sake. Yes, who else want to try? Yes, that's the first girl to talk today. Sit down and talk loud.
Potential difference can be defined as...
Can you hear her at back?
Potential difference can be defined as the work done in moving a unit positive charge from one point to another in a closed cycle.
Let us please clap for her. Please, you are not here for social gathering. That day, I was telling you that the only way you can make difference is just close and open. That should have made it easier for you to. Now we define electromotive force. They say an open circuit. You don't need anybody to whisper anything or to say anything before you quickly say, okay, potential difference is now the work done in moving the unit positive from one point to another in an electric circuit, in a closed electric circuit. That's the definition I expect you to give. Of course, it is potential difference across the cell when the cell is delivering current to the circuit. And we represent this with capital letter V as C. And according to Ohm's law, potential difference can be expressed as the product of external resistance and the current. According to Ohm's law, the external potential difference V can be expressed as I R. Of course, from the definition given here, from this you can say E equals I into R plus small letter r. If you open bracket here, you have IR plus I small letter r. Do you know that IR here is simply known as V plus small letter V? This is external potential difference. This is internal potential difference. External potential difference and internal potential difference. From equation 2, V is called external potential difference. Then E is electromotive force. Of course, you can say EMF. That's another abbreviation. Then small letter V is internal potential difference. Internal potential difference, which is also known as loss volts. We also refer to it as loss volts. Internal potential difference or loss volts. So these are two. This is equation 1, and this will now serve as equation 2. These are two possible ways by which you can use to calculate the external potential difference. And the instrument we can use to do that is voltmeter. When the battery is working as it defined, when the battery is delivering current, whatever be the reading across the cell at that time, when the battery is working, whatever be the voltage across it while it is working, that voltage is called external potential difference. But when the cell is not delivering current, whatever voltage across its terminal is called electromotive force. The difference between electromotive force and external potential difference is the loss volt, which is also known as internal potential difference. Now, the next one is resistance. We can find the external resistance can be determined and the internal. Before the external, let's talk about number 3. 3 now that we can obtain is effective internal resistance. Effective internal resistance can be obtained. That's small letter R total. Effective internal resistance can be determined. Effective internal resistance can be determined. When you talk about effective, that means you are talking about a circuit that contains more than one cell. If effective internal resistance is talked about, that means you have more than one cell in the circuit. A cell, you only talk about internal resistance of the cell. But when you have more than one cell, then you can be talking about combining their internal resistance. And that's when we talk about effective internal resistance. Am I communicating? And effective internal resistance is represented by small letter R total. So you have two possible arrangements. Because internal resistance comes from the cell. And you can only have two possible arrangements in cell, series and parallel. You can't have misarrangement in cell. So it's not possible to have misarrangement of cell. So here you can only have series or parallel arrangement. So for series, in series arrangement of cells. For series arrangement of cells, the effective internal resistance, can be obtained by using R, small letter R total equals R1 plus R2 plus R3 plus Rn. Depending on how many many cells you have in the circuit. It depends on how many cells we have in the circuit. We are going to add each internal resistance of the cell together. When the cells are arranged in series, we add all their internal resistance together to obtain effective internal resistance. Addition of their internal resistance give effective. I told you effective is also known as total resistance or equivalent resistance. Once the cell is in series, we combine the internal resistance of each of the cells by adding them together. That's how we obtain the effective internal resistance of cells in series. But for parallel, the formula for parallel arrangement, of course, then before that we can say where R total is called effective internal resistance. Effective internal resistance. R1 is internal resistance of cell 1, R2 is internal resistance of cell 2, cell 3, depending on how many cells you have in series. We add them together. So R1 and 2 are internal resistance of the cells. So you can say R1, R2, etc. are internal resistance of each of the cells. Each of the cells. So that's series. But for parallel, you can say in parallel arrangement of cells, you have the effective internal resistance can be obtained. Internal resistance can be obtained by using that can be obtained by using expression 1 over R total equals 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 and so on. And say plus da, da, da. This is the expression we use to calculate the effective internal resistance of the cells in parallel, arranged in parallel. I told you there are two possible arrangements for cell. So we have series and parallel. That means you have two different formula for calculating the effective internal resistance of the cell. In a circuit, if the cell is not in series, the cell will be in parallel. So if you don't use the series R1 plus R2 plus R3, then it will be 1 over R total. That's when it is in parallel. Any circuit, any calculation you meet in the circuit, so one of the two will solve the internal resistance, effective internal resistance. So that is that. Having done that, number 4 will now be external. Effective external resistance. Effective external resistance. Effective internal resistance. That's number 4 of the quantity obtainable. 4. We have effective external resistance. Effective external resistance. Effective external resistance. Effective external resistance can be obtained. That is the resistance outside the cell. The resistance outside the cell are referred to as effective. That means when we say effective, you have more than one resistor. If you connect 2 resistors or 3, then you can talk about external resistance alone. It has to be effective. Effective means combination of all the resistance that are not in the cell. Combination of resistance that are not in the cell. The resistance in the cell are referred to as internal resistance. The one outside the cell are referred to as external resistance. If you have 1 resistor in the circuit, it's just going to be external resistance. But if you have 2 resistors, then it will now be effective external resistance. That means combination of resistance outside the cell. I hope I'm communicating. Yes. And the resistors, external resistors, have 3 possible ways by which you can combine it. We have series arrangement, we have parallel arrangement, and of course you may have mixed arrangement. You may have series arrangement of resistors, you may have parallel arrangement of resistor, and you may have mixed arrangement of resistor. There can never be mixed arrangement of cell. But for external resistor, you may have mixed arrangement. I hope I'm communicating. Yes. You may have a cell containing 2 cells. 2 resistors in series. The 2 resistors will be arranged in parallel. And if you have 3 resistors, it may be, what do I mean? You may have resistor like this. You may have resistor 2. You may have like this. And it may be like this. You have like this. You may have like this. And it may be combination. You have 3. You may have like this. 3 of them. Connected to the circuit. These are possible arrangements you can have in a circuit. That's maybe joined to other components in the circuit. So you need to combine the resistance here. You need to combine resistance here. You need to combine resistance. In each of these, we find R total here. R total will simply be R1 plus R2. Of course, this is called series arrangement. That's series arrangement. R, you can say where R total is called effective external resistance. That's what you have in series. But for this is called parallel arrangement. So if you want parallel arrangement here, it's going to be 1 all over R total equals 1 over R1 plus 1 over R2, because there are 2 of them. That is parallel. This arrangement is called parallel arrangement. That's called parallel arrangement. And this type of one is called mixed arrangement. That means you first of all combine these 2. If this is R1, this is R2, this is R3. Combine these together. First, it becomes R1 plus R2 parallel to R3 total. You need to find it before you finally find R total. So there are two steps to obtain effective external resistance here. You first of all find the combination of R2 and R3, get the answer to that. You now add the two together to get it. So because R2 is parallel to R3, you are going to say 1 over R2 parallel to R3 total. 1 over this equals 1 over R2 plus 1 over R3. So that you can get the value of this and put it here. When the value of this is known, we now add the two. There is now series. Add together to obtain the last answer you're actually looking for. You cannot calculate this answer without combining this one first. Step 1 is to combine these two, collapse them to get their equivalent. When you find the total of this, you put the value here. The two of them are now in series. Add them together to get it. This is what we call effective external resistance. This is what we call effective, and this is what we call effective. These are possible ways you can have in any circuit. It's either we have 3 resistors connected in series, or connected in parallel, or in mixed arrangement. Is that taken? So that is number 4. That's effective external resistance. Now 5. Electric current. From the circuit, you can work out electric current. From the circuit, you can obtain electric current. From the circuit, yes, obtain electric current. We can calculate electric current in the circuit. How do we calculate electric current in the circuit? Right from the first electromotive formula I gave to you. I, electric current, this can be obtained by using the expression I equals E all over R plus internal resistance. That is 1. Electric current. We use this one when we have one cell. What you have there is one cell, one resistor in the circuit. When you have one cell, one resistor, we can use this. That's when we have one cell and one resistor in the circuit. So we can use the expression. Then where I stand for electric current, E stands for electromotive force. You may not write all full all the time. EMF is enough. You can simply say EMF. That's it. Then you have R as external resistance. External resistance and R is internal resistance. These are what you need. You have 4 parameters. You have 4 parameters. 3 out of 4 will be given to obtain the 4th one. Mind you, you have one cell and one resistor. Once you have more than that, then we have to combine. So you can also have, it can also be E total all over R log R total. When do we use this? When we have 2 or more cells and 1 resistor. 2 or more cells and 1 resistor. When you have 2 or more cells, you know internal resistance comes from the cell. E total comes from the cell. Once you have 2 cells, then internal resistance must be total. You have to combine them. But you have 1 resistor, you use that. But if you have more than 1 resistor in the circuit too, you have to find the effective of that. I hope that is clear. It all depends on the question that is given to you that will determine which of these you are going to use. So it is possible to have this, or you have more than resistor. You can also say I equals E total all over R total plus R total. These are expressions you can use to determine electric current in the circuit. These are the expressions we can use to determine the yes, in the circuit. That's number 5. Of course, where V equals internal potential difference, I electric current, and R is internal resistance. Internal resistance. This is expression 1. It can also be expressed as small letter V equals electromotive force minus this. It can also be expressed as this. This is equation 2, where of course you have V to be internal potential difference. E is electromotive force, and capital letter V is equals to external potential difference. Then lastly, I'll just give you that to discuss that next class. We have electric energy, which is, you can say E equals, these are the expressions to calculate this from the circle. IVT. IVT, that's equation 1. Or you can say I squared RT, equation 2 for electrical energy. You can also say E equal V squared over RT. That's another one. E can be PT. So these are expressions for electrical energy, where of course where E stands for electric energy, then I stand for electric current, V stand for potential difference, R stand for resistance, that's external resistance, and of course T stands for time, P stands for power. The last but not the least is electric power. Electric power. That's where we stop today. Electric power is the last one. And what to do to get the expression for electric power is to remove all T's from here. So number 8, obtainable quantity, the 8th one, is called electric power. And we can express power as IV, I've removed T. Power can be I R, like this, I remove T. Power can be V squared over R, I remove T. And power here can be E over T. These are the expressions. Every other parameters here have been defined here except the time. Please, in your own interest, if you digest all what you are given tonight under an hour, and you know it very well, it's going to help you in jam and also your exam, level 1 YA. There is no way you will sit for questions. This is exam, that question under the electricity will not be asked. This is direct current. All questions that will come across under direct current to be found here. The other part will now be that of potentiometer and meter bridge. Potentiometer, meter bridge, and wisdom bridge. And under 30 minutes, I can explain. Since I explained part of it in the practical class, you can talk about potentiometer, how to calculate potentiometer, meter bridge, and wisdom bridge. Everything under direct current is over. So, we may not be able to solve questions under this next Wednesday, but I expect you to go and lay hands on as many as possible questions and bring questions that pose problems to you to the class. I want to go back to waves and optics.